Assalamualaikum and hi to everyone. Thank you for watching this video. So in this video, we will discuss about the local area network, the standard internet, uh, the IEEE standard, and then based on that part, what is the evolution of the internet? We talk about the standard internet first. Okay, in 1985, the Computer Science Society of the IEEE started a project called Project 802. So this project is set up in order to create a standard that allow the communication among multiple or variety of the equipment from the different manufacturers. So the project 802 is a way of specifying the function of the physical layer and the data link layers of the major LAN protocol. And when we talk about the hardware, the device, the equipment, it must be under the physical layer and data link layer. So this one is a standard from the OSI. At the left side, this one is standard from the OSI and the internet model. And then the right side is the standard that developed by the 8EEE. So basically, it's quite similar. However, under IEEE standard, we have data link divided into two parts. We have the first sublayer we call as the logical link control, and the second sublayer we call as the media access control. Okay, this one is the general format of the frame, comparing from the HDLC frame and LLC PDU, as well as the MAC frame. So inside the frame, there is several segmentation, and basically those all of the frame have the header, and at the header part is contain the addresses for the destination as well as the source addresses, and then followed by the data and the control part. So for the HDLC frame, we have address segmentation, and then control, and then upper layer data, and then we have FCS. Okay, and then for the LLC PDU, we have the destination source access point, the source service access point, and then followed by the control, and then we have the upper layer data. For the MAC frame, we have the MAC header, and then we have the MAC payload, and followed by the FCS. Okay. Until now, supposedly all of you know that the standard come out by the IEEE, and actually those standards are equivalent with the standard under the OSI model as well as the internet model. So the layers that affected are data link layer and the physical layers. Okay, the next part we go for the Ethernet evolution under the standard Ethernet. So the original Ethernet was created in 1976 at the Xerox Palo Alto Research Center Park, and then based on that project or research, it come out or it evolved until the fourth generation. So the fourth generation of the Ethernet, we have the standard Ethernet, also known as the traditional standard of Internet, and then we have the fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet. The difference of those Ethernet are the speed of the data rate, the bit rate. So standard Ethernet, or refer to the traditional Ethernet, we have 10 megabit per second. Fast Ethernet content of 100 megabit per second. Gigabit Ethernet, we have 1 gigabit per second, and 10 gigabit Ethernet, the speed is 10 gigabit per second. So time by time, the speed is increasing. So now we talk about the standard Ethernet first. So under this part, we look at the MAC sublayer and the physical layer, and then the addressing and the physical layer implementation. So this is the format for the MAC frame. we have the preamble, SFD. This one known as the header of the mainframe. And then we have the destination address, the source address, the length or time, and the data padding, CRC, for the detection error. So preamble here content of 7 bytes, and SFD content of 1 byte. So total at here we have 8 bytes. And then the address for the destination and source is based on the physical MAC address. So physical MAC address we content of 6 bytes of size. So this one is size for the addresses, physical addresses. And then we have the length for 2 bytes, followed by the data and the detection error. So we go through segment by segment. The first one, we have the preamble. This part or this segment is for alert you or alert the receiving system to the coming frame and allow the synchronization in its input timing. SFD, start frame delimiter. This one at the beginning of the frame, and it notify the station that this is the last chance for them to do the synchronization. And then followed by the destination address. The destination address content of 6 bytes, or the size is equal to 6 bytes. So physical address of the destination or the receiver side. And then we have source address, content of the physical address of the sender side. And then followed by the length. This one is type of protocol that being used for the transmission. And then we have the data carries encapsulated under the data and padding here. So the minimum size of data and padding is equal to 46 and the maximum is 1500 bytes. And then followed by the CRC content of 4 bytes of size. So this one is referred to CRC 32. So the minimum and the maximum length for this frame, minimum is equal to 64 bytes and the maximum length of this frame is equal to 1580 bytes, 18 bytes. So these are the minimum and the maximum. We exclude the preamble and the SFD. We only cover from the destination to the CRC. Okay, for the data padding, the minimum is 46 bytes and the maximum payload is equal to 1500 bytes. So how to calculate the 6 byte from the destination and the source address here? Because this one is based on the physical address of the stations. So it's based on the physical address. So basically the physical address content of 12 hexadigit. So 12 hexadigit equal to 48 bits. So 48 bit divided by 8 equal to 6 byte. Okay, now how to identify either the address is unicast, multicast or broadcast. Okay, first, based on the addresses, based on the physical address, look at the first byte of the address and look at the last bit of the first byte of the physical address. If the last bit is equal to 0, that means the address is a unicast address. And if the last bit of the first byte is equal to 1, that means that is the multicast address. How about the broadcast? If all digits for the address is equal to 1, so that means it is a broadcast address. So look at this example. Define the type of the following destination addresses. Look for the A first. We have 4A, 301021, 101A. Convert all to the binary numbers. So we look at the first byte. So the first byte is 4A. When we convert this hexadecimal into the binary number, 4A become 0100 1010. So 1010 is the last bit. Look at the last bit. Last bit is 0. So that means this is a unicast address. The next part, B47201B2E08EE. So look at the first byte. First byte is 47. Change this first byte into the binary number. Then you will get 0100. 0, 1, 1, 1. 7 is equal to 0, 1, 1, 1. So the last bit is equal to 1. That means this is the multicast address. And how about the C? Okay, this one is F. All the digits equal to F. F in hexadecimal, when you convert, it's become 1, 1, 1, 1. So that means all the digits are equal to 1. This is broadcast address. Simple. Okay, the next one. Show how the address 47201B2E08 EE is sent out on line. How the process of send out. So the process of send out, first you need to convert all the digits into the binary number. From 47201B2E08 EE, convert become 10100 into the binary numbers. And then it will send left to the right, byte by byte. Left to the right, byte by byte. So that means it will send 47 first, and then 20, and then 1B, and then 2E, 08, EE. And for each byte, it is sent right to the left. So that means it sends 7 first, then 4. Okay, for this example, let's we convert this 47. 47 equal to 0100, 0111. So it will send this first byte first, and it will send from the right to the left. So the right side is 7. So 7 is equal to 0, 1, 1, 1. So it will send 1, 1, 1, 0. Okay, here 1, 1, 1, 0. And then 4 equal to 0, 1, 0, 0. So it will send 0, 0, 1, 0, 0, 0, 1, 0. So that's all. The first thing, you need to convert the hexadecimal into the binary, and then follow these rules. Left to the right for the byte, left to the right for the byte, right to the left for the bits. Okay, the next one, we go for the standard Ethernet, also known as the traditional Ethernet. So the implementation of this standard Ethernet, we have 10 base phi, 10 base 2, 10 base T, and 10 base F. So 10 base phi, using the bus topology, type of the media is thick coaxial cable. 10 base 2, using the bus topology, type of the cable is thin coaxial cable. 10 base T, star topology, untwisted pair cable. And 10 base F, star topology, fiber optic cable. So the speed for the standard Ethernet is equal to 10 megabit per second, and it implements the encoding and decoding. So the line coding for this standard Ethernet is Manchester. So look at this implementation. For 10 base phi, we have 10 megabit per second. The transmission is baseband transmission, and the maximum distance of the cable is equal to 500 meter for the coaxial cable. For the transceiver cable, maximum is 50 meter. Bus topology. For 10 base 2, 10 megabit per second baseband transmission. The maximum distance is 185 meters. Okay, it uses the bus topology. So this cable is coaxial, thin cable, 185 meters. The maximum, the laser is better. Okay, the next one, we have 10 base T. In the previous one, we use the single cable. Okay, this part 10 base T, we use the 2 pairs of UTP cable. So it used 2 pairs of the UTP cable. Okay, the topology is star topology. The distance of this twisted pair cable is 100 meters. And then it still use the baseband digital transmission. The next one, we have 10 base F. This 10 base F using the fiber optic cable. 2 fiber optic cables use the star topology, and the maximum distance for the fiber optic is equal to 2000 meters. Baseband transmission. So in summary, this is the summary for the standard Ethernet implementation. We have 10 base phi, thick cable, 500 meter, line coding is Manchester. All the standard internet implementation using the line coding of Manchester's. And then we have used different type of media access based on the characteristic. If we use 10 base 5, so thick cable, thick coaxial cable. If we use 10 base 2, thin coaxial cable. If we want to use 10 base T, 2 UTP cable. And if we want to use 10 base F, 2 fiber optic cable. So different type of cable have different maximum distance. Maximum distance means that when the signal go through inside the transmission medium, there are certain limit that the data can be accepted or not. Okay, when the signal travel from one point to another point, we need to make sure that the distance is suitable enough for the signal to transmit the right data, the correct data, and the accurate data within that speed. Okay, so that's all for the standard internet implementation. So the next video we'll talk about the fast internet, 1 gigabit internet and 10 gigabit internet. Thank you and Assalamualaikum.